All right, so the first thing, when Steve asked me to do this, I really didn't know what to say, if you wanted the truth. I just teach. I don't really think about it. So I've been doing it for not quite as long, but I've been doing it, teaching statistics classes for, I guess, 18 years. So my experience is, I've taught, basically, in Canada at 5 different universities. I taught here at Oxford for 3 years. And I also give workshops every year, several of them. So this year I'm giving a workshop at Stanford, at Ohio State. I give these things quite often. I have varied experiences, from people who are really motivated and really want to be there, all the way down to people who really don't want to be there. And in Canada, the way it works there is that in most sociology departments, you have to take an undergraduate course in statistics. So that's usually a 12 to 14 week course where you're in the classroom 3 to 4 hours a week. Sometimes it's a full year course, so you've got 2 semesters, so up to 28 weeks. And you have to take that in almost every department. So there'd be a combination of methods and statistics. If it's just, some would just be methods and you won't have to do the statistics part. But I think it's fair to say that the programs with the most respect, those that are held in the highest regard, they have lots of quantitative training. Even among the people who aren't quantitative researchers, I think that people would say it just happens that those programs make sure we have it. So Toronto, McGill, McMaster, Western, UBC, these are our best sociology departments, and they all have lots of training in quantitative methods. So that's where I'm coming from, and I'm going to give you some, based on my experiences, mostly in Canada. That's what I'm going to talk about today. So what's the outline? First thing I want to talk about is expectations. I think those expectations are probably going to be similar to what you're dealing with. What the students expect, and how you handle those expectations, how you get through to those students, because a lot of them don't want to be there. So you have to figure out, how do I get through them? And not only do they not want to be there, you have to be willing to admit right off the bat that most of them can't do this stuff very well. And that's just the truth, at least where I come from. They went into sociology because they don't like math, and it's not only they don't like it, a lot of them didn't have the aptitude. So in high school, they took the bare minimum of mathematics that they had to get into university. They just don't want to do this. Some of them you can turn around, and that's what I see my job. I'm happy if at the end, people came in hating it, and if I have just a few, even if I get 20% of the class at the end say, geez, I love that stuff. I didn't know that I didn't know what I could do with it, and I really love it. And they find out they do have an aptitude for it. That's my goal. And so that's how I look at it. I'm not out there to train methodologists in an undergraduate course. I do graduate courses too, and that's where I'm trying to do that. But even there, I'm going to tell you that most of those grad students don't want to be there either, at least in our program. And we have a highly quantitative program, one of the most in sociology, one of the highest, most quantitative departments in the world, probably. And yet still, half the students do not want to take this stuff. These courses cause them anxiety, and it's a course that at the end, people feel like dropping out of the program because of these courses. Okay? So that's where I'm coming from. That's the kind of student that I have to get to. I'm not teaching just to the good one. I care about the good one too, but I want to get to those ones who I know are nervous about it. Okay? So you got to figure out how much can you expect from them, and I'll talk about that. So am I trying to produce? So the second part of my talk will be about goals for the courses. Am I trying to produce methodologists? Or am I just trying to produce competent practitioners, critical consumers? What do I want out of this? At the undergraduate, I'm going to tell you right now, almost nothing. All I want at that level is for them to be able to understand the basic concepts so that when they go further, they can read. I'm not going to go so far in an undergraduate course. Some people do go further, by the way, but I think it's a complete waste of time. I'm not going to go so far that they can read everything in the ASR. That's a waste of my time. I'm not going to even get them partway there. I'm not getting them anywhere near there. I'm getting them ready to do the next course that might get them there. So I'm going to talk about how many courses you need and how far you go. So the first step is just getting them to understand basic concepts, and that's that first course. And that's going to take me 12 weeks. And so that's fundamentally different from the way it's done here at Oxford. When I taught here at Oxford, the way it's done here at Oxford is the wrong way, in my view. It is the wrong way. It's the way to get people to not learn very much at all. I always said that when I was here, right? See, this is not, and that's the way it's done almost everywhere, right? I'm saying you have to start with the basics. You have to make sure people have a fundamental understanding of those important concepts. Not the math so much. You know, I'm trained as a statistician and as a sociologist. I probably should have said that. So I know the maths, but you know what? I'm not showing them that much of that. We're going to do some hand calculations of that first course, but the emphasis isn't on that. It's so that they can see what that method is doing, but it's not, oh, I'm caring about if you got the math right. I'm caring more if they understand the math. Okay? So that's the goals of my course. I'll go into detail and the different levels as I get there. So then I'm going to talk about my general approach to teaching statistics. I've already given you some of that. I have this idea that I'm going to demystify it. I want people to understand this stuff. I'm not going to be one of these guys who says, if you cannot use LaTeX, then you're not a methodologist. There's people in the political methodology community who say that all the time. That just makes no sense. I'm trying to teach you how to understand a method. I'm not trying to teach you, that's my goal anyway. My goal is to teach you the method so you understand it. My goal isn't to teach you a method so that you can go out and say, look at me, I'm an elitist. I'm a methodologist. It's about demystifying. Okay? That's how I approach the course. And you know what? If you do that, I find you can get through to people. Okay? If you put on the facade that, hey, I'm the big shot, I teach the statistics, which a lot of people do, you're going to lose half of them right off the bat. Okay? So I emphasize telling a story from the data. I'm very, very close to the data when I teach a course. It's about telling the right story. So I'm going to emphasize a lot of diagnostics, explaining how a method works, and how things can go wrong because of an outlier. How when I'm talking about linear regression, if I don't even check for linearity, how can I even expect to talk about a linear regression? I'm going to show those kinds of things. I'm going to make it clear so they understand the method. If you don't do that, and you just spit out coefficients, people don't know where those coefficients come from. And what I'm also going to do is emphasize the importance on explaining the trends in your data first, before you talk anything about inference. I'm not jumping ahead to my standard errors. I don't really care at the beginning. I do at the end. Of course, those standard errors let me say something about a population. But they don't make any sense if I haven't described the sample right. And those are the kinds of things that I'm talking about with demystifying. Can you explain what you see in your data first? Once you've explained what you see in your data, then we talk about saying if what I see in my data makes any sense, or make any sense of what's going on in the population from what I see in my data. Okay? That's my general approach. It's about getting close to the data, understanding what it means, and understanding the method. Then I go to inference. But even then, I'm going to tell you later, you got to be very careful how you explain how inference works. Back to demystifying things. You got to let people know that this is a guess. It's all a guess. You know, and your students aren't going to know that unless you tell them that very clearly and explicitly. They sit wondering all the time, where do these things come from? They don't understand the sampling distribution, for example. So that is a big key when I teach an undergraduate course. I spend a lot of time on the sampling distribution, explaining to them what it is, so they know it's a guess. It's not, you know, it's part art, part science, right? Statistics. There's a lot of guessing, and they got to know that. The minute you don't tell them that, that's when it's mystified, right? Where did that come from? So for me, it's all about making sure I demystify. I'll end with some discussion of practical aspects. What do I do in my courses? So for tests, I do some unusual things. Some things, again, partly because I care about them learning it, nothing else. So I tell them everything that's on the test before they have a test. Everything. Everything. I'm not, for a grad test, grad exam, I give them the exam. Go home. Read the exam. Spend a week horsing around, studying it. Do it all, do whatever you want. You're going to come into the test, you're going to come into the exam without anything from outside, just your pens and papers and your calculator. But I'm going to let you see the test before you come in, because that's going to, it's going to ease your nerves. It's going to let you know, and you're going to learn the material. That's all they care about, is learning the material. Okay? So I'll give you some advice on what I do. And as I said, when I started out this, I thought, well, I don't really do anything special. And I started realizing I do a lot of strange things. You know, I do things that other people don't do. And maybe that's why it works. I don't know. So, first, let's start with expectations. As I said earlier, at least where I come from, and I think it's generally the case, unless they're going into a social statistics program, but if you're in a sociology program, it's generally the case that most are taking statistics, for sure at the undergraduate level, because they have to. Okay? If they really liked it, most of them would have been in economics. They wouldn't have gone to sociology, right? They went there because they really want to avoid that stuff. Most, not all. I went to sociology because I love the subject matter. I did better in math than I did in anything in high school, but I just like the subject matter. So there are exceptions, but I'm saying most of the people do not want to do this. You have to know that, and you have to accept that. At least that's how I look at it. You accept that. You don't say, I don't like those students. Well, that's what you got. You've been hired to, I look at it this way, I've been hired to teach people. So that's what I got, so I got to figure out how I get through to them. Okay? If you don't do that, you're not gonna have any success. That's how I look at it. You know, if you try to be all, well, you don't like it, that's too bad. It's not gonna work. And you also have to remember they have very little math background. Most have none. I mean, when you get to central tendency, they have trouble. You know, they have trouble with the mean, the mode, and the median. And you're going, what the heck? How can you have trouble with that? But they do. And so you have to acknowledge that, and you have to work on those things. Okay? And because of that, they're afraid of the course. End of view. They absolutely hate their stats professors, at least where I come from, at the beginning. At the end, they usually like me. But that's because I'm demystifying it. Right? I'm trying to get them to understand the importance of this stuff and what they can do with it. They want to learn it because they want a good grade, so they're uninterested. The only reason they want to learn is for a good grade. So it's your job, at least I see it as my job, to make the material interesting and relevant. What I mean, anytime I can take something from the newspaper and bring it into class about a statistic and say, look, here's why they got it wrong, which happens 50% of the time when you see something in the paper, right? Here's why they got it wrong. Here's why they're overstepping their claims. I'll do that. And I'll say, if you know statistics, you see what I'm talking about. So you can be an informed consumer in the world, not just in sociology. But most important, what am I trying to do? I'm trying to prepare them for the next course. When I have undergraduates, that's all I'm doing. They're not going to leave there knowing how to do a whole lot. At least not in my classes. I have colleagues who will go right into logistic regression at undergraduate level. And what I'm going to tell you, all they produce is people who are dangerous with the computer. Because they go on hit buttons, say, look, I got some stars, and they don't know what they mean. A bunch of asterisks beside the coefficient, and they say, I found significance. So it means something. And you know what else they do? They change significance, right? They just go and recode variables and change things around, put new variables in, until they find the story they want to tell. That's the kind of storytelling I want to discourage. Okay? I want them to understand what's going on so they don't do that. And if you go too far, that's all you're going to have. That's how I look at it. That's all you're going to get. And you know what? That's probably 80% of people who do quantitative research. I bet you if I took the ASR and I went through it, I bet you I could, if I could read you all their analysis, I bet you I could find mistakes in 80% of what's in there. Big ones, big ones. And I'll give you an example. Look at this very famous quantitative sociologist. She was in fact head of the methodology section recently. She had an article in the 80s. I'm not going to say who it was, but you'll get it figured out. showing their outliers. She didn't show. She said there was a major finding. Somebody came and redid her analysis, found that it was really a few outliers that caused the finding. She showed something quite different than everything everybody else had found. Take those out and they disappeared. That's the kind of careful analysis that is very important. You know, you have to be close to your data to find those things. So, you're going to get more of that. By the way, she's a very good quantitative sociologist. That was just one mistake. It was 30 years ago, and it was harder to detect things then also, okay? But we can do this easier today. Anyway, graduate students. My experience is that I get 2 a year. So our program is not that big. I mean, we're a big department. We have 65 faculty members, but we only let in 15 PhDs a year. We try to get the best ones from around the country. We only let in 15. 2 of that 15, they really, really like this stuff. They came to work with me. Okay, they want to do quantitative stuff. 5 others, I'm going to be able to turn around. They went in thinking, I don't know if I want to do this. They're going to, by the end of it, they're going to say, this is good. They might not become methodologists, but they're not going to be afraid of it anymore, and they might even start doing quantitative research. The rest, the other half, I'm not going to ever change them over. They're really that much against it. But what I hope to do is by the end of their course, they're competent consumers. You can read it. And I'll make the argument that if you can't read quantitative stuff, no matter what you're doing, you're going to miss half the literature because you're not going to understand it. And if you want to be a good social scientist, you've got to know what others have done first to make sure that you can tell the right story with your data, right? So at least I'll get that. I'll try my best to do that. But I'm still going to have 2 or 3 at the end, maybe. Just hate me. You know, so I'll get 9 out of 10 scores by everybody else, and then I'll get 2, 3 from those 2 who just hate me, right? You just can't do anything about it. And you gotta, here's my advice, you gotta just say, oh, I did my best, and know that that's what you got. You know? But there's something else about grad students you gotta remember. They're highly competitive, at least where I am. I'm sure it's the case everywhere. They're highly competitive. They do not want their peers to know they don't know something. A lot of them. They don't want me to know they don't know. That poses different kinds of challenges. It means I have to make sure that I have one-on-one interactions with them. So I have to have a lot of office hours. I have to have a lot of assignments so I can detect when there's problems, and I talk to them about the problems. Fortunately, I can do that because the class isn't too large, right? With the grad course, I have, I can do a lot of things I can't do with an undergraduate course. But you have to too, because they're not going to tell you the same. You know, some do, but a lot don't. At least where I am. Okay, so that's what I'm dealing with the students. So what am I trying to get out of this then? So what are the goals of the courses? Well, I want them to be curious. I hope that's getting obvious. I want them to want to learn this stuff. To be curious about the world, and to see this as a tool for them to be able to learn something about the world. I really want to get that message across. I don't want them to see this as a hoop that they have to go through, even though it is. I don't want them to see that is the only reason they're doing this. Okay? I try very early to let them know that. I give a spiel like I'm giving to you right now. I say, listen, it's not just a hoop. You're going to learn something here. And that's when I come in with real-world explanations or examples to show them that. For example, how can you learn anything about poverty without statistics? Can you talk to 20 people and know how bad poverty is in a country? I don't think so. I want to know how many people are in poverty, right? I got to count them. Okay? I got to know how much income they have, what they can buy, what their standard of living is. I have to measure things. So I'll give those kinds of stories in more detail than I'm giving now. But I'll have examples. You want to learn about things that matter. You want to learn about them? Sometimes you need numbers. Not always, but sometimes. And of course, as I said, I want to make sure they have a solid understanding of basic concepts, so that when they go on, they're not lost. And the problem we have at U of T is students who came from other places, because we give them that solid understanding, or we think we do, we try to. And when we bring in graduate students from other places who are trained in smaller departments, where quantitative methods are not given the same respect, sometimes they are, but sometimes they're not. I'm talking when they come from one of those departments where they're not given the same respect, they're lost. Okay, so we actually have. I'll talk more about sequence of courses later, but we actually have what we call an MA stats course. Basically, that's what we see as an undergraduate level stats course. It's this basic foundation course, and we make anybody who didn't take ours undergrad course take that course, because otherwise they'll be in trouble. So I'm going to have formulas in that undergrad course for sure. You're going to figure out, you're going to go right up and figure out a linear regression by hand. But it's not because I want them to worry so much about the math. The number of cases will be very small. Okay? It's because I want them to see how when you do this, what's going on in the formula. I'm subtracting the mean, I'm dividing by standard deviation, so they understand what's going on. And I'll explain that to them at every step. I don't just throw a formula and then I say, go home and do that. Explain to them what's going on with it. But I'm most likely going to use graphs. So if I want to show them regression, I'm going to draw a scatter plot, and I'm going to put a line on it to show them, look, how would I figure out a best fit? Well, I'm going to minimize those vertical distances. Why between the points and the line? When I add them all up, what's the smallest number I'm going to get? I'll try to explain it in common sense language, how that works. Grad course, a little different. By the time we're done there, that first course, I want them to be I'm hoping they can evaluate, or at least get part of the way there, understand most of what's being done, even if they don't know the method. They'll be able to look for it. They'll be able to look and see, understand the basic idea of what they've done with the method. It's not to that next course that I'm going to get to things. So I'll get to that later. But the first stats course you're going to get, I'm going to the generalized linear model and no further. The first stats course, that's as far as I'm getting. No further. No mixed models. No hierarchical linear models, which are part of the mixed model. No generalized additive models. No time series. No structural equation models. Nothing. Because they're not going to really understand that unless they really understand the generalized linear model. And if I skip over that, then they're not going to know that when I go and do a structural equation model, that I better check for all those outliers and nonlinearities through the whole thing, because the assumption is that there's linearity. And all I've done to fit that model is chase covariance. I just put a covariance matrix in and say, spit it out. Then they're not even going to understand if there's a covariance matrix. How the heck can I have reciprocal causation with observational data at one point in time? They're going to think they can because the method allows you to do it, but they're not going to fundamentally understand that maybe there's a problem with doing that conceptually. Maybe we should think about it anyway. Maybe we should realize that we're adding another layer of assumptions. We already make assumptions when we do inference. Now we're making assumptions when we even look at the pattern in the data. Those are the kinds of things that if they want to do it, fine, but they should know that before they get to it. And that's how I look at it anyway. So that second course, that's when they're prepared to do competent research. In fact, they leave our first course, and if they're doing generalized linear models and no further, so a Bolger model, a Colbert model, a Poisson regression, something like that, they can really do that well. They can really do that well, because we teach them all the diagnostics. They can really do that well. But if they go any further, they're going to have to come and talk to me for the next method if they haven't taken the second course. Then I'm going to have to help them. I think. I hope they come to me. I hope they don't just go click some buttons and think that they got the right way to do it. I hope they either come to me or they read on their own, and if they're reading and they have problems, they come to me. because they haven't learned it. Okay? So even in that third course, you know how much they learn? They do that for a week. So it's an introduction. If you really want to learn structural equation models, you got to take a course on it. If you really want to learn time series, you got to take a course on it. If you really want to learn mixed models, you got to take a course on it. You can't go and take a day on it, 2 days on it. You just can't. You're going to miss all the things that matter. You're going to think you know it, but you don't. You know? So that's how I look at it. Really, this is about building blocks. You know, you can't miss a step in the middle, or you're in trouble. And you might not. The problem for me with it is, they don't know, but they don't know. That's what really is frustrating for me. They don't know. They don't know. Okay. So my general approach then, I've given a lot of that already. Emphasis on concepts and the process of statistical analysis. I'm going to provide a guide for decision making. It's not really a recipe book, but it almost is. Okay? I'm going to tell you, here's what I do. I follow things in a step. You know, I'm doing a model, I fit a model. First thing I do is I look at every distribution. I don't look at the distributions to see if they're normal. How many students think that the X variables have to be normally distributed? You gotta get rid of all these ideas right at the beginning. You know why they think it? Because they're taught that a lot of times. So here's the other thing I'm saying. Before you teach something, my advice for me, I never teach anything unless I really feel like I got a firm grasp of it myself. And if a teacher's telling students that the X's, that the independent variables have to be normally distributed, or even that Y has to be normally distributed, then they don't understand the method. They don't understand the method. We're talking about the errors being normally distributed. It's possible that the errors will be normally distributed even if Y isn't. Okay? And certainly it matters nothing about X. Otherwise we could have no dummy variables in our model. They're not normally distributed. Okay, so those kind of messages have to be given very early. It's about concepts. It's about understanding what's going on. And too often we're not giving them that. So, what's that mean? I'm removing the mystery, explaining the logic behind what goes on. It's not about being elitist. I actually hate that. I want people to learn. I don't want them to go around thinking, oh, people who are quantitative are better and we think we're better. That's crap. I mean, we're not. Right? Qualitative data can be just as important. Depends on the question. You want them to know that too, because I do. I want them to come into the class and say, I have a problem. What is the best way to investigate that problem? Not, I have a method, but I'm going to apply that to some data. What should I do? No, that's backwards, man. You know, I don't want that. So if we're truly concerned about learning about the world, the more people understand the statistics, the better. Okay? And you probably have seen this quote as much as I have, right? There are 3 kinds of lies. Lies, damn lies, and statistics. I think it's actually Mark Twain who said it, right? But he attributed it to Israeli. The point is, you can make statistics tell you whatever story you want. Definitely true. So now you got to make sure that you teach students to tell the right story. Not the story that gets them in the big journal. That's how I look at it. If the story comes out and it's not going to get you in the big journal, oh well. You know how many orphans I have? I got a folder on my computer where I have 12 folders of papers that I started that I thought were brilliant ideas, and they're just sitting there because you know what? The results were not interesting enough to publish in a good journal, and I just decided I'm leaving them behind and I'm going on to something else. I'm not going to force it. Not going to change the story. It didn't fit what I wanted. There's going to be an honest scientist about it. Okay? And that's what I try to encourage people to think about. It's about science, but it's also about art. Telling the story is the art part. Okay? And even the science part, as I said, a lot of the science is guess, right? You know, the sampling distribution is a guess. It's all a guess. There's all kinds of uncertainty when we're doing these things, and you have to make sure you tell the students that. This is a guess. This is not a fact. This is a guess. They don't understand that. If they don't get that message, then they don't understand the statistics. The minute you tell them that, and you explain it clearly, they start to go, okay, I can see what you're doing. But if you don't let them know that, they wander around wondering where the heck this stuff comes from. They really do. So I let the students in on the secret right off the bat. That is, you can lie with these, but you shouldn't. I don't say you can't lie with statistics. You know, the qualitative researchers who hate statisticians, who hate quantitative research because they say they can't tell the truth. Well, they're going too far too. We can tell the truth with it, but it is true that some people don't tell the truth. And I don't want my students to be those. And a lot of times it's just because they don't know. You know, they're making mistakes along the way. So they're telling lies without even knowing they're telling lies. Although you can certainly lie on purpose too. You know, you choose a method that gives you the right answer. So you fit a model with 3 different methods and you say, I want that one. How does that work? I fit a model with 3 different answers, I get 3 different answers, I go, uh-oh, what's going on? And if the methods are complicated enough that I can't get underneath to figure out why they're different, again, it's one of my orphans. You know, unless I can make a really solid justification for why that method I use is the best one, and why the other one might have something wrong, I've lost confidence in it now. I've totally lost confidence. If I fit a mixed model or a multi-level model and I change things around, add a variable and another thing gets all whacked out, unless I know why that variable being added should cause it to be whacked out, I don't know if I should keep doing it anymore. So I investigate hard to figure out, why did it change? I might spend a week or 2 doing that. Why? What's going on? You know? And if I can't, it's an orphan. I'm not saying that to the ASR, gets published, and then somebody comes to me, hey, you missed this and you missed that. Hey, I got a big publication, no consequence, other than I know that I didn't do it right. Nobody else knows. But that's not how I operate. I think I'm in the business of trying to create good scientists. Okay, so that's how and then I think if you tell students in that, if you teach them in that way, they get excited. You know, it's a lot different. You know, they know that you're not always going to find a good result. It's more frustrating. My students are frustrated to work with me sometimes. They come with me, they have a result, and so I tell them, bring it to my grad students. Go out and have a beer with them, bring the laptop, let's have a look here, we'll have a coffee, sit down. I take it, I rerun it, do some diagnostics, find a little problem, because I didn't believe the result in the first place. I wipe it out. They're so frustrated. I said, which story do you want to tell? What story do you believe? Well, yours. Well, but I wish you didn't find it. Why? You wanted to publish something that doesn't make any sense? So, and that's usually how it is, by the way, in my experience. If I find something that doesn't make sense, it probably doesn't make sense. You know, social science is largely common sense. We don't want to admit to it, but it is largely common sense. If something is really whacked out, it's probably not real. You know, I'm going to hammer and away at it to find out if it's real or not. And I'm almost always going to find something that hammers it out if it's real. You know? That's the approach I take. To make sure I got the right story. To make sure I'm not telling lies. And when I do that with students, they actually get excited. As I said, sometimes they get frustrated when they're working on their own papers. But I'm talking about teaching the course. When I can show them I can whack away at things, and maybe change stories. Oh, wow. I mean, if I learn this, I can learn how to make a difference. Then I spend a lot of time on a model when I get to the 2nd and 3rd courses. Okay, again, it's about telling the right story. Are we describing or are we explaining? Well, I'm telling you, in my view, I'm always describing the sample. Always describing. And that's fundamentally different approach than others who look at everything in causation language. Always describing. From there, I might make causal inferences, but they're based on theory. No statistical model will give me that. Right? Panel data gets me closer, change over time, but even then, I can never be certain. So it's the theory that's going to give me the causal argument. The statistical model will never give me that. And that's the story that I give to my students. By the way, not everybody believes that. Some people think you can go and use 2-stage least squares and You can look at reciprocal causation. Okay, I say it's voodoo. Okay? And that's how I teach it. Again, you see, I'm always trying to debunk things. I tell them to think about it. Does it make sense to say that some other variables are related to one but not to the other? And if I put that in there, I can tell you causation at one point in time? I'll get more detail on it than that. But those are the kinds of things that I talk about in the class. Think about what you're doing before you do it. I consulted once, just as an aside, when I was a grad student. A faculty member came to ask me about structural equation models. She's in political science. She said, I've been fitting these structural equation models. Can you have a look at them for me? Basically teach her how to do them with her. So she paid me some good money to do that under a grant. And the first thing she did was show me the output. And she had a path that went from some attitude to sex. And it was going both ways. And I said, what's that? Oh, the modification indices told me that there's a path there. And they mean the model fits better if I have that path, right? That's right. That's true. You know, because it uses things like two-stage least squares. That makes sense, yeah. It's going to fit better. You're going to explain more of that dependent variable. That's right. But can you tell me if that makes sense? What do you mean? Does it make sense that your attitude changed your sex? Anyway, that's the kind of this was a faculty member, see? So it's back to what I said. Trained at a pretty good university, pretty good department in the U.S. Okay? So that's back to what I was saying about going too fast and not really understanding what's below it. Okay?
Was the dependent variable sex in the term of male or female, or whether you were...
No, male and female. That's right.
So people were changing sex as a result of having...
That's right. That's what I mean. It was just, it's a true story. It's a true story.
And she hadn't even seen this.
Sorry?
She actually had not seen that.
Well, she saw it. She put it there.
Yes, but I think had she thought it through?
No,
was she really only looking at an output and a diagnostic?
That's right. So she behaved like a robot. It said that the modification indices changes the chi-square by this much. It says it'll change the chi-square by this much. It'll reduce by this much if you add this path in the model. So I
still can't quite understand what a model is which actually has got the outcome being that you are male or female.
Well, it really isn't, though. I mean, that's the point. But
any model at all. I mean, in other words, I can't quite see why she had that on the...
She had it as a predictor. And so if you know structural equation models, so you have a set of equations, and it was saying come back now. Come back now. It had a path going back to them. So she didn't put it there originally, but the output told her that if you add that, the model fits better. But that's, this is what I mean. If you don't understand what's below, that's an extreme case, but if you don't understand what's below, those are the kinds of things people do. And, they're desperate. They just, am I doing it right? Those are the things they do. And the other thing I emphasize a lot is how to effectively present those results when I'm done. So that the students make sense of it, but also so that their readers can make sense of it. But by doing that, they understand it better. So I'll never, ever, if I have a logit model, for example, I'll never just report the coefficients and the standard errors. I never report the odds ratio either. To me, that's nearly as useless. I never report that. What I report instead is fitted probabilities. Okay, holding other variables constant. What is the relationship between one x and y in terms of the probability that y is going to occur? Okay, I always do that kind of thing, especially not just for nonlinear models like a Probit model or a logit model, Poisson regression or whatever, but even for a linear model, when I have interactions. Okay? I'll either create tables of fitted probability or sort of fitted values, or I'll draw graphs. You want people to understand what you've done. So that's a general principle for me. But if I teach it that way, the students better understand. And it's more interesting for them. they see results come out that make sense, instead of coefficients that even the best mathematical mind can't figure out what they mean when there's a complicated model. They just know it goes up or it goes down, and that's it. So I've already said this very clearly. I'm always talking about limitations. Always. So much so that the other guy in my department who teaches statistics, he doesn't like that I do that. So when students go through him, they're just automatically going to a mixed model or a multi-level model. And I'm automatically telling them, make sure you know why you're doing that. Make sure you need to do that. So I'm testing things. I'm looking to see if things work. I don't have a prescription for what the model I should use automatically should be. I have an idea of the ones that are best to use, but I check for different things to make sure that's the one I should use. And those are the kinds of things that, again, part of the demystifying. You show the limitations, then people start to understand it a little more. I think they get more interested, really, I do. You know? Again, I've already alluded to this as I've been talking. Problems with causal inference, I really, in contrast to the big movement that's going on in both sociology and political science that says we can find causation with certain methods, I think it's nearly all a waste of time. That's just me. I think it's an academic exercise. I think if the idea is really to discuss what's going on in the world, it's not going to get us much further. And we're better off just to get down to the nitty-gritty and find the relationships and then talk about causation in a theoretical way. That's my view. So I make sure that they know that, and that's where I spend some time talking about the difference between observational studies and experimental studies, where you might get better purchase, definitely will actually. But I should clarify, most of the stuff that I'm teaching is observational studies, observational data, right? And that's the reason. But it's certainly going to get further with the causation idea with experimental data. Omitted variable bias, confounding variables, mediation, moderation, all these things, I make sure that I'm defining or explaining these things very clearly. What are the consequences of leaving out a variable, for example? One thing we don't do well enough, but I think is very important, is measurement. You know, it doesn't make sense to, again, talk about relationships if you haven't measured your variables very well. And so I've been talking mostly about statistics and how I teach statistics courses. So the first thing I have to say is that before I even get to the statistics course, I think it's important. I don't teach it myself because we just don't do it in our program, in our grad program. But I think you need a very, very good, and this is where we're limited, you need a very, very good methods course first, where you talk about how you collect data. Even if you're never going to collect it yourself, so you know how they were collected, and you know the consequences of the ways they were collected from your models later. Right? You need that. You need to know how you measure variables, so that when you're looking at relationships between things, that they make sense. I mean, if you measure something wrong, it doesn't matter if it has a strong effect on another variable. Right? If it doesn't make, if you look at the measurement, it doesn't make any sense, then the relationship means nothing too. And I think it's very important to get that early on, before you get to the statistics. I didn't put much of that in here because I guess I just thought it was about teaching statistics, but now I get here and I realize it's about methods generally, right? So I think it's very important that you do that first. Okay? And then the other big thing is inference and the sampling distribution. This is very, very important. And I find in the years that I've been teaching that this is where students get lost. This is where they get lost when they get to grad school and they still don't know. They think they know what a p-value is, and they can interpret a p-value, but they really don't know what it means. Even some of the better methodology students. They didn't really get taught it well. It's something that was glossed over, and they figured out how to do an hypothesis test. You know, they could go through the motions, figure out, a p-value, and make a judgment on the hypothesis test, but they really didn't fully understand the sampling distribution. So I think it's very important to make this clear early, so they can understand that these are educated guesses. Okay? And so one of the things I do as an example in an undergrad course, I'll show them how the sampling distribution works by putting everybody's, I'll number each person in the class, it's 100 people or something. Put 100 numbers in a hat, envelope actually, and pull them out randomly. Take samples of 3 or 4. I'll ask people their height, and from their height I'll calculate the average height. So the first thing I'll do is find what's the population average height. So all 100 people, what's the average height? And from there then I'll go and take samples of 3 or 4. And I'll do that, I don't know, 50 times. Depends on how much time I have. And I'll construct a sampling distribution of size n, or size 3 or 4, whatever it is. And I'll show them. You know, you do this example, and the mean of that sampling distribution is going to pretty much be right on that mean in the populations, and they'll start to understand where you're coming from. And then I'm going to show them, I'll use that sampling distribution to make those guesses on where the one that we have might be, or how far it might be from the real one. Okay. So again, I'm trying to show them a real world example of how something that's theoretical actually works. Okay. You know, once you do that, about half the class, the light bulb goes on. The other half, honestly, I'm never going to get it. But I can get that other half, right? And I would have only had 10% of them before, if that. So practical aspects. I think this is, again, I'm saying this as I go along, but the sequence of the courses is very important. It's a building process. I really don't think it's even good for you or for me to go take a course unless I have the background. Jump into something, and, you know, it just doesn't make any sense. You're missing half the stuff, right? So first course is a methods course. I just said that. But once I get past that, that first statistics course is going to be very simple. It's a basic course. I'm going to get to linear regression, and I'm not even going to get to multiple regression. I'm going to get to simple linear regression, and that's it. Okay? We talked about the general ideas of identifying outliers and nonlinearity. I can find that in a simple case, which is obviously very easy. The next course, this one we get go a little bit further. Then I'm going to get into generalized linear models. I'm going to take off from where we were. I'll go to multiple regression first, and generalized linear models. I'll show how they build on the linear model case. If you're lucky enough to have students with an aptitude for math, I always like to do a class, just one class on basic matrix algebra, basic, very small things, and show them how regression, how regression is done in matrix form. Because if you can get that through to them, and that depends on your students if you can do it or not. But if you can get that through to them, then when I go to the GLMs, I go to mixed models, I go to robust regression. When I extend the models, they all build on that. You can show them little tweaks in using the matrices, like in the model matrix, what's done, and it's very easy to understand them. But you have to have that matrix algebra background, so that's a matter of if you have the students at a level where you can give them that one class. Really, it only takes the one class, but they have to have enough of a math background to be able to do it. If you can, then go into these more difficult models, or these more complex models. It's very easy. And I'll tell you right now, if you can't do that, they're never really going to get it. Just telling you the truth. They're never really going to get it. If you don't get that in matrix form, if you don't understand the matrix form, you're never really going to get it. You might get some of it, but you're never really going to get it. That's the truth. And that's what, again, part of my idea, that how far do I go? You're going to get the ideas, but you're never going to really get inside it. You know? For statistics course, now this is where I go to these, as I said, robust regression, generalized additive models, mixed models. I'll take 4. I don't do more than 4 there. Four advanced topics, and I'll look at, what's going on in the literature, what our students might need. So in my students, we don't need time series, although I've taught that elsewhere at ICP and R and things like that. My students don't need time series, so I never even touch that. And most sociologists don't need time series. So if you go and spend time on time series, you've just wasted their time. Okay? Try to find, that's how I look at it. Try to find the things that they're likely to use. Even generalized additive models. Some might say, oh, they're not going to use that, but you know, the way I teach it, they're going to use that as a diagnostic to test for linearity, for nonlinearity. And it's not that hard to do if you understand it. So I give it to them. Robust regression. Probably not going to use it that often, but again, I use that as a diagnostic tool. So they can identify outliers in multidimensional space. Okay. Mixed models, of course, that's all the rage for the last 10 years, right? So you have to show them, or HLF, you have to show them that. So that's the kinds of things. Structural equation models, I really try to avoid it. Because, you know, I'm well trained in it, but I really try to avoid it because I don't like it. I think that there's too many assumptions and too hard to check them. So I really don't like them. You know, I call it chasing covariance. That's what people do. They take a covariance matrix, they throw it in, and they say, look, I've got all these causal relationships. That's what they do, you know. So they're not looking at all those causal relationships, each one of them. If you can do that, it's hard to do that because you're estimating it all at the same time. But if you can go look individually at each linear regression first and identify problems, take those out and then fit it all at once, I think that's better. And even then, I'm not sure that it's going to get what you want. Well, it might get what you want. I'm not sure you're going to get the right story. So that's my view on it. Okay, I prefer David Cox's approach, which is the graphical chain approach, where you just regress on everything that came before it in the causal chain. That way I can identify any problems each time I'm doing it. But I often will teach that because it's used. Less and less so, you know. It was the HLM of the 90s, right? Okay, practical aspects. Again, so what do? I combine lectures and labs and tutorials. So for both undergraduate and graduate courses. So they'll have weekly assignments and typically 2 or 3 exams depending on how I feel that year, or tests. Okay? I use a data projector as I'm doing now, but I usually have point form on there, and I'm going to tell you the truth, that's for me. It's really not for them. I'll give them the lectures only after, but they're not helpful. They're really not that helpful. And why? I used to give them everything. And when I come to do a workshop, I do give them everything. But if I'm teaching at home, I don't. Why? Because they don't show up at class. And you know what? I'm going to tell them a lot more that they're not going to get on the slides. They're going to learn. They could learn it from a book as well. They're going to use my slides, right? I'm going to show them things that I can't even put on a slide. Tell them things I can't even put on a slide, right? So I don't give them till after. When they get them, I don't think students even care to have them after they come to the class and they see how I use them. They're not that useful. They're useful in that they told them what topics are covered, but you know, if they read the readings, they see that too. So it's not that useful. Anyway, I make them available, and I use the whiteboard a lot. I'm always drawing things, to making pictures. I don't use it so much for formulas. They're on the slides, actually. I use it to draw pictures, to explain concepts. And something that's different from what we're doing now, and I find this a little awkward actually, I like a conversation, even in a big class. So I'm constantly answering questions the whole lecture. And that's why I look at it this way, at least you have to really know the material before you go in there if you want to teach this well. Because if you're afraid to answer a question, you lost, and the students can see that, you lost their confidence and you're done for the rest of the year. I found that out my first year. So that's it. That never happens again. Right? You're done. You stand there and turn red and you don't have an answer. Because they're usually simple questions. The more I do it, now they're all simple. It's seldom I get stuck. And if I get stuck, I'll have to look it up for you. That's not a straightforward, there's not a straightforward answer, at least that I can see. And then it's okay. But if you can't answer those little things, so if you can't explain to them the sampling distribution very clearly when they ask you, and unless you take some time, chances are you probably can't. I'm just going to be honest. I know most people how they were trained, and unless you take the time to really do that, so that when you're answering the question, you can spit it back very quickly. You lost them, and as soon as you lost them, you're done for the year. That's my experience, or at least it was. Hasn't happened in 18 years. Happened first year, so it never happens again. Okay. Anyway, so I got these weekly assignments. I encourage students to work in groups, but their assignments are going to be their own. They better write it up themselves. I don't care if they're doing, figuring things out together. I think that's good. I have no problem with students talking to each other, but their assignments better be their own. And in a grad course, you can tell, right? I can see if they've been written alone, and they better be. And I'm very clear about that at the beginning. It's your work, but you can talk to people, because in the real world, as academics, we do talk to people. I have no problem with that. The assignment better be your own, because otherwise you don't learn, right? If you go and do things in a group, I actually hate group work in that respect. I hate it. Because you know what happens? The one who's really good at the math ends up doing all the work, and then somebody else who's really good at writing does all the writing. So the one who can write never learned any statistics. The one who can do the math never really learned any statistics either. They just learned the math. Nobody learned how to do the process, and it's a waste of time. And then some people are even annoyed with it. When I was a grad student, I was annoyed because I didn't want anybody writing my own stuff. I didn't want anybody doing anything. Let me do it myself, because I'm going to do it better than everybody else. That's how I thought. I guess that's arrogant, but it's just true. I did not want to be having any free riders on my coattails. Let me do my work. So they got that issue too. So that's it. I let them work in groups, but they must do their own write-up. I'm not a fan of letting students use their own data. I absolutely hate it. I'm not a fan at all. When I give data, and I give them a question, I've worked it out very carefully. And in fact, I often give data from my own research. So I know the story. I worked for months on it. So I know what they're going to find. So if I give them a project, here, I want you to go test these hypotheses, I know what they're going to find. And if they don't find it, I know they didn't do it right. But if I give them their own data, if I allow them to use their own data for projects, I can't check everybody's stuff. That's one thing. Who knows if it even works? So what do you end up doing? They end up chasing significance. So now I said chasing covariance, now I'm saying chasing significance. They're looking for stars. They're reconstructing stories, trying to make things work. But if I give them my own data, I know exactly what they should find. Okay? And I think that's the only way I can really evaluate them and then identify serious problems. And then you let everybody do their own thing, you can't help them. You might even think they wrote something good, but it might be wrong. They might be one of these people telling lies with statistics, and you don't know. And now you can say, oh, they don't do that. Sure they do. Come on. You should know that. Students do that stuff all the time. Okay. Tests and exams. For undergraduate courses, I'll review the class before. I always have a review, and I go over all the important concepts. I won't go over, so let's say we were doing t-tests and had to calculate a regression or something by hand. I won't go over that again. I'll go over the ideas, how they work, how you make decisions on what test you use, and so on. I'll spend a lot of time on that. And then I'll actually read to them the test. I'll read it fast enough that they can't write it down. So then you say, what a waste of time. Yeah, it is, in a way. But I'll tell you what it does is it eases it calms their nerves. Because there's no uncertainty coming into the exam. So they have a week. They should have been studying already. We know most of them aren't. But they have a week now to go home. And they know what to expect on the exam, which is almost everything, by the way. I mean, I don't really leave too much out. So it's not that helpful in a way, but believe it or not, it really works. And for their anxiety. They feel a whole lot better about it. Strange, but true. And I go even further with graduate courses. I give them the exam, as I said already. Take it home. Do whatever you want. Do all the analysis, whatever it is in the exam. In fact, you better. And then when you come into the class, you can't take any of that stuff with you. You're going to start from scratch. But in a way, you should already know what to do. but I want to answer questions about it. So I should mention that. I'm very, very accessible until I give them the exam. That's the deal I make with them. You want the exam? Yes. Here's the deal. The minute I give it to you, I don't answer any more questions because the exam period has started. You can ask whoever you want, I don't care, but you can't ask me. Everybody puts up there, they say yes or no. Yes, everybody says, okay, it's a good deal. And that's it, don't talk to them again. Because I consider that, even though they haven't done it yet, that's the start of the exam period. But I don't care who else they talk to. Because at the end of the day, they gotta come in and write it anyway. But I'm not gonna tell them the right answer. That's for them to figure it out. And as I said, I have extensive office hours. I spend a lot of time in my office. And people actually come. If you make sure that you make sure to let them know that you're happy to help them, they come. Especially grad students. Remember I told you they're competitive with each other? So they're not going to be in the classroom showing their weaknesses. Undergraduates, they don't care. Because they know that 80% of them are just like them. So they don't mind showing the weakness. Because they know that the other 80% hates it. They hate it. They're not good at it. They don't care. Grad students, even if they hate it, they don't want to show that weakness to their other students. They don't want to show that weakness to you. Or some of them anyway. But if they come face to face, and you encourage them to come, and if I look at their assignments and I can see the mistakes they made, I can encourage them to come one-on-one before it gets too good. That's it. I think that's it. Must be stuff. Thanks.
Thank you.